Welcome back to our statistics series where we explore different statistical techniques and their application. In today's episode, we'll be diving into the world of two-way ANOVA, a powerful tool used to analyze the effects of two grouping variables on a response variable. So grab a cup of coffee and let's get started. Before we begin, let's quickly recap what two-way ANOVA is all about. This statistical test allows us to evaluate the simultaneous effect of two grouping variables, also known as factors, on a response variable. Each factor consists of different categories or levels, which can vary in number. To demonstrate the process, we will be using a data set from a bakery. Let us load the data and take a peek at its structure. So I have already loaded the data, and let's see what the data looks like. We will print the data. So this is what the data looks like. With observation, display height, display width and demand, and the structure of it will be, so we have a total of 120 observation with 4 variables, and all of the variables here are integers. In this data set we have two factors, the display height, which is dh, and the display width, dw. The levels for dh are bottom, middle and top, 1 being bottom, 2 being middle, 3 being top, and 1 being normal for width and 2 being the white. Now we have to convert the variables into factor. As we can see from the structure, both our variables are in integer form, which is wrong. So we will convert both of them into factors before we further move. Okay, now as we have converted them into factor, we have to state our hypothesis. So we want to test if there is any significant difference between the levels of factor A, which is the DH, factor B, DW, and the interaction between them. Our null hypothesis is denoted by H0 A, H0 B, and H0 AB, states that there is no significant difference between the levels of factor A, B, and their interaction respectively. On the other hand, we have our alternative hypothesis, which is H1A, H1B, and H1AB. State that at least two levels within each factor or their interaction differ significantly. Now that we have our hypothesis set up, it's time to perform the two-way ANOVA analysis. Let's run the model using the AOV function in R. So there are different methods. We can also find ANOVA by using LM, which is finding linear regression and then summarize it, or use the function ANOVA. But over here we will use AOV function. So this is a model because we have demand as a response variable and TDH and TDW are our factors, and to the power square I have done it so we can also get the interaction effect. The model has been run. Now we will summarize it. Okay, so we have got the summary with degree of freedom, sum of square, mean sum of square, f value and the p value. So now let's find the interpretations of this summary table. So we have fitted our two-way model to the data set, regressing the demand variable on both DH and DW factors and their interaction. In ANOVA results reveal some very interesting insight. The p-value for DH is extremely small, as we can see. The 3 stars shows the significance, highly significance, indicating that the level of display height have a significant effect on demand. But TDW, meaning the width is not significant, is 0.6, means it's not even significant at 5% level of significance. So it has no significance whatsoever. But similarly, p-value for the interaction effect term, which with the height and the width, is significant again. suggesting that a combination of display height and display width level has a significant impact on demand. Now we know that which factors of ours is given is significant. Now to further explore these differences, we can conduct multiple comparison tests. In this case, we will be using Tukey's honestly significant difference test. But there are other comparison tests like LSD and Duncan test too that can be used as well. So we will run the test. Okay. So we can see running the Tukey's HSD test allows us to compare the mean of different levels and identify which pairs are significantly different from one another. And the result of the Tukey's HSD test indicate that there are significant difference between all the three pairs of display height. So all the combination 2 by 1, 3 by 1 or 3 by 2, all of them p-values are significantly quite small. So they're all significant. And you have it by conducting a two-way test, ANOVA analysis, and performing multiple comparison tests. We were able to uncover the effects of display height, display width, and their interaction on demand in our bakery dataset. Understanding the impact of these factors can help bakery owners make informed decisions such as adjusting the display strategies to maximize demand for the product. Now, the combination also we can see that a lot of them are significant, while some few like this one, which is 0.9447, which is the combination of height of 1:2 and the width of 3:1, which combination is not significant except for two such combination. Most of them are in combination is also significant. So that wraps up today's episode on two-way ANOVA. I hope you found this exploration of statistical analysis enlightening and valuable. Join us next time as we continue our statistical journey. Thank you for watching.